Okay, so now I'm going to talk about triacylglycerols. So triacylglycerols, this topic is because this is about how human cells actually store energy. So most cells store small amounts of glycogen for use when demand for energy is high. But when human cells have more energy or more than they need, what they can do is they have these certain cells called adipocytes, which are adipose tissue, and they're almost entirely filled with triacylglycerols. And what they are, triacylglycerols is just the efficient storing mechanism that humans use to store fatty acids. This is the most abundant lipid in the human body, and the molecule you need to know what glycerol is. So glycerol is the actual technical name for this would be where are we at? 1, 2, 3 propane triol, right? There we go. So 1, 2, 3 propane triol. 1, 2, 3 because we're indicating where the hydroxyl groups are. It's a triol, so it's 3 carbons with 3 hydroxyl groups on 1, 2, 3. Fairly simple structure, but this is how the human body stores lipids. And the way we store lipids is, if you think about it, lipids are a carboxylic acid, right? They may be a long chain carboxylic acid. And we can react carboxylic acids with alcohols, right? And that reaction is esterification. So what ends up happening is we make 3 esters. So you can put 3 alcohol groups on 1 glycerol. So triacylglycerols are triesters. So the word acyl, that's referring to an acyl group it's the carboxylic acid without the OH. So, and the YL ending should indicate to you that we're talking about a substituent. So I'll draw the long bond there. So an acyl group is this part. So what we have is we have glycerol with 3 acyl groups attached. It's a triester. So triacylglycerol is a lipid formed by the esterification of 3 fatty acids onto a glycerol. So here we go. So usually these are going to be really long chain, acids, and they can be unsaturated, saturated, polysaturated, monosaturated, whatever. There's 2 types of triacylglycerols, and one is a simple, which is R1, R2, and R3 are all the same. So it's 3 of the same fatty acid. Those actually, we don't see many of those in the human body, actually. What we have mostly are mixed triacylglycerols. Because the human body is just storing fats. That's all that's happening. You're just taking the fats that it has, putting it onto a glycerol, and putting it in storage in an adipocyte. So this triester has different kinds of fatty acid molecules on it. Now, I will say there's a difference between fats and oils. You've probably heard the terms fats and oils, and maybe or maybe didn't know what the difference was. And literally, the only difference is a fat is something that is solid at room temperature. An oil is something that's a liquid at room temperature. Now, if you remember way back to talking about physical properties back in chapter 12 and 13, more unsaturation, so more double bonds. Right, if we have the more double bonds we have, the lower the boiling point gets, and therefore the lower the melting point gets. They track together. So something that has more double bonds, and that's simply because you're taking away hydrogens that can contribute to London forces. So compared to the unsaturated. So unsaturated fats, things with double bonds in them, tend to be oils. They're often unsaturated because that lowers the the melting point, so they tend to be liquids at room temperature. Fats tend to have stronger intermolecular forces because they are usually saturated. So you'll hear saturated fats. You don't usually hear saturated oils. Fats are usually saturated. This saturation gives them higher boiling points and therefore higher melting points. And at room temperature, that means that the room temperature is actually below that melting point, so it's still a solid. Another distinction is fats usually come from animals and oils usually come from plants. And this is no accident. Fats are solids at room temperatures, but to be functional in a living organism, they can't be a solid. They would just glob up and clog up arteries or whatever transport tube that particular organism has. Animals tend to be warm-blooded. Not all of them are, but they do tend to be warmer, right? So, particularly mammals have higher body temperatures, and so our bodies are warm enough that fats melt. At room temperature, they would solidify again, and this is a problem for plants. Plants don't have the luxury of having high body temperature, so they have to have lower melting, more easier melting substances and oils. So that's usually why oils come from plants and sometimes fish. But really, the distinction between what we call a fat and an oil has to do with its physical state at room temperature, not where it comes from. There's just a strong correlation there. That's really all I'm going to say about fats and oils and triacylglycerols. I'll talk about reactions to triacylglycerols next.